So what I would recommend from here is, let's get out a whole different sheet of paper. And again, trig is very quickly going to be getting harder and harder with more and more things for us to remember. And let's try to come back from lunch and get right into it. All right, we got a couple of Chromebook distractions. Let's try to. Now, I'm going to turn my paper sideways like this. So it's long ways, so it's looking landscape or horizontal. Now that we're here, I'm going to draw a nice line down the middle. And I'm going to label this side trig, and I'm going to label this side quadrants. And our goal here is to think about the x and the y and the r. Okay, sure, but really our goal is, when is it positive? Okay, so over here on the trig side, let's put sine theta. And who's sine theta's buddy? Cosecant, CSC theta. Because those are pretty much the same thing, they're just upside down, and when you flip a fraction upside down, it doesn't change the sign. So sine and cosecant, those are going to be little buddies. Then of course you got cosine, who's cosine's buddy? Secant. And then of course you got tangent, and who's tangent's buddy? This is the easy one, cotangent. Okay.
Cotangent.
Interesting. And our idea here specifically is, when are these, let me go back to this one here, please. When are these positive? Because, you know, you're either going to be positive or you're going to be negative. Now, in that first quadrant, let me just sketch really quick. In this first quadrant, we're going positive x, positive y. The r is always considered to be positive. Is there any reason that anybody should ever be negative in the first quadrant? No. Everybody's good in the first quadrant. So, is sine and cosecant positive in the first quadrant? Yes. In the first quadrant, everybody should be positive. The x's are positive, the y's are positive, the r's are positive. Everybody's positive in the first quadrant. So that means also cosine and secant are positive in the first quadrant, and also tangent and cotangent are positive in the first quadrant. Okay, everybody's positive in the first quadrant. Now, if we just kind of get rid of that and we do the same thing, now we're over here in the second quadrant. We've got x, y, r. The r is always positive. Let's talk about the x. Is that positive or negative? Negative. And the y? Positive. So our sine is going to be opposite hypotenuse, positive, positive. What do we think about our sine? Quadrant 2, positive. Let's look at our cosine. Cosine is going to be adjacent hypotenuse, negative, positive. Will cosine be positive? No. And let's look at our tangent. Opposite, adjacent, positive, negative. Is tangent going to be positive? No. So, in quadrant 2, sine, positive, cosecant, positive, cosine, negative. Tangent, negative. The only one that's looking positive in 2 is going to be sine. Now let's talk about quadrant 3. We're down here, and now we're negative x and negative y. The r is always considered to be positive. Sine, opposite hypotenuse, is sine positive? No. What about cosine, adjacent hypotenuse? No. What about tangent, opposite adjacent? Negative, negative. 2 negatives makes a positive. So tangent in the third quadrant is going to be positive. So that's why I put a little positive down there. And if we're kind of seeing what's going on here, which one do you think is going to be positive in the fourth quadrant? Cosine. let's just make sure, I'll do this mega fast triangle. We got plus x minus y plus r. Cosine positive, positive, good. Sine negative, positive, bad. Tangent negative, positive, bad. So just like we thought. Cosine is going to be positive in that fourth quadrant. So if I were to grab my calculator and I were to type the cosine of 200, do you think that's going to be a positive number or a negative number? 200 is in the third quadrant, and cosine is only positive in 1 and 4. It is, right? It's negative, okay? Your function is always going to be positive like half the time and negative half the time, right? 2 out of 4, 2 out of 4, 2 out of 4. So you can't just kind of say sine's always positive. Huh? Sine's positive in 1, 2, negative in 3, 4. So it's always, everybody gets 2 positives and 2 negatives. Now, we're going to take that same information, and just for the sake of making this such a good reference, is we're going to do the same thing, and we're going to rearrange this into quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And we're just going to take that same information Who is positive in quadrant 1?
Everybody.
Everybody. Sine is, cosine is, cosine is, cosine. Everybody wins. Who is positive in quadrant 2? Look right here. Positive.
Sine.
Sine. Sine and cosecant. Who is positive in 3? Who is positive in 4? Okay, we got it listed right here. 4 cosine. Now, with this sheet of paper, you pretty much got it on lock. Who's positive where, who's negative, would just be the opposites. You got all the information you would need right here. And we did a lot of math reasoning, and maybe that math reasoning becomes a little bit hard to remember. So here's what people will say. They'll say ASTC, goodness. And there's a bunch of different little things for this. So sometimes you'll hear all students take calculus, right? Not everybody takes calculus. I like to have a smart trig class, right? But if we fail the test on Tuesday, it's going to be a stupid trig class. So let's make sure we learn this, and we can keep it to the nice one where it says a smart trig class, and we'll be in good shape. So if you need to, if you need to memorize this, if you're thinking to yourself, okay, I have this piece of paper, but on the test I'm getting really nervous, I'm going to forget all this. A smart trig class, 1, 2, 3, 4, all sine, tangent, cosine. Okay, now let's go back. Let's go back to our notes here. Let's see if now we have this, it makes this work here way easier. It definitely should. If the terminal side lies in quadrant 4, would you expect y over x to be positive or negative? Now y over x in quadrant 4, that would be like the tangent. I would expect it to be negative. Remember, the only thing in quadrant 4 that's positive is cosine. And cosine is adjacent and hypotenuse. It's definitely not x's and y's. It needs an r in there or an h. So yeah, I would expect it to be negative. If cosine is positive but sine is negative, which quadrant are we in? Cosine has to be positive. That could be in 1 where everybody's positive, but sine is negative. So it can't be quadrant 1. That means it has to be quadrant 4. If cosine of theta is less than 0, what does it mean if something's less than 0? It's negative. So if cosine is negative and cotangent is positive, where are we? Quadrant 3. This has been built based on which ones are positive. So when I do a question like this, it says the cosine is less than 0. I'm not worried about that much. I'm really focused on this. That, which is the positive portion, says where is cotangent positive, so I can look around. Cotangent's positive in 1 and 3, but this now tells me, well, they're not all positive. So then I say, oh, okay, well then it must be number 3. All right, flip it over to the back. How are we feeling now that we have our little cheat sheet here? We doing a little bit better? Okay. Let's look at number 2. We're going to skip number 1 for now. We're going to do number 2 real quick. Using the given conditions, find the exact value of each of the remaining trigonometric functions. Okay. It tells us that the cosine of theta is 3/7. I'll tell you this right now, one of these 6 is very easy. What's the cosine of theta? 3/7. It's got to give you one of them. It's got to give you something to get started. And if cosine is obvious, then its buddy is also pretty obvious. What's its buddy going to be? 7/3. Now cosine is A/H. So we know that the A is 3 and the H is 7. The problem is that sine needs the O. Tangent needs the O. How are we going to figure that out? Right, draw a triangle, do a little Pythagorean theorem. Cosine is 3/7. That does not look like a perfect Pythagorean triple to me, so I might get a little square root answer here. My Pythagorean theorem would be a squared plus b squared equals c squared. Remember that the 7 has to be your c value because it's the hypotenuse. And so I'm working with 3 squared plus b squared equals 7 squared. That's 9 plus b squared equals 49. Subtract my 9 to the other side. B squared equals 40. And then square root 40. You know what, square root 40, we're going to have to make that look a little nicer. Square root 40, what are 2 numbers that work with 40?
4 and 2.
4 and 10. And I know that 4 is my perfect square. So simplified, this is going to be 2 square root 10. Okay, so we just figured out the other side is 2 square root 10. That's our opposite. Now we should be able to do this question and feel really good about it. What is the sine going to be? Opposite hypotenuse? 2 square root 10/7. Our cosecant? 7/2 square root 10. Our tangent? Opposite over adjacent? 2 square root 10/3. Our cotangent? Flip it upside down. 3/2 square root 10. Everything we've done here is 100% a review. This is nothing new from today. Here comes the new stuff from today. When is it positive? When is it negative? What's supposed to be positive? What's supposed to be negative? We got 2 bits of information. The first one is that cosine is positive. So we know this is positive, this is positive. That gives us 2 options. If cosine is positive, either everybody's positive in number 1, or only cosine in number 4. Then we get this piece of information. Sine is negative. Okay, that means sine is negative. That means cosecant is negative. But it didn't tell us any information about tangent. Is tangent going to be positive or negative? negative. Remember, either everybody's positive or only one of them's positive. Well, two of them, because these are buddies, they kind of work the same. So that's going to be negative. Negative. Now the very last thing about this is that we do have two parts here with the square root in the denominator. And so if we really want to get the best possible, all the points on the quiz, we do need to rationalize these denominators. Negative 7 square root 10 over 20 and negative 3 square root 10 over 20. These are just a little bit better because they have that rational denominator. Put the square root of 10 on the top, make it a regular 10 on the bottom. Should be okay. Okay. Last one we're gonna do is number 1. Doing number 1, we get a very similar bit of information. We're gonna hear about the secant. Ooh, don't do that. Come on, pen, please. The secant is negative square root 2. Awesome. The secant, negative square root 2. It's very easy. And the terminal side of theta lies in quadrant 3. Quadrant 3. In quadrant 3, only tangent is positive. So that means that, let me erase this little bit of mess we have here. That means that this should be negative, 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 negative. Only tangent is positive. And of course cotangent, because they're buddies. Now we need to find the rest of the trig functions, which means we need to use this number here, square root 2. And I'll tell you this right now, they love this question. They give you a square root 2. They give you a square root 3. They give you something a little tricky like that. We like it when they give us a fraction, because that fraction is an O and an A, or an O and an H, or an A and an H. This is not a fraction. They've tried to trick you here. This square root 2 is a square root 2 over 1. And that is how we're going to take our triangle, right? Every number can be divided by 1. Secant. What letters is secant? A over H, H over A, O over A. What is secant? Nice. It's the upside down of cosine. It's H over A. So let's do our triangle. The H, square root 2. The A, 1. We need to figure out what that third side is. This one's a really easy one. Nice small numbers. Little Pythagorean theorem really quick. 1 squared plus b squared equals square root 2 squared. 1 squared is 1. B squared. What is the square root of 2 squared? 2. Subtract the 1 to the other side. Subtract the 1 to the other side, you're going to get 2 minus 1, which is just 1. B squared equals 1, and square root 1, what's the square root of 1? 1. 1 and the square root of 2. Okay? So now our only job, we've already got the signs figured out, is just make our little fractions and be done. So, the cosine should be pretty easy. It's the upside down of that. It's going to be 1 over square root 2. And if we wanted that to look a little bit nicer, what would it be? Negative square root 2 over 2. That's a nicer version of it. With that square root out of the bottom. Okay, sine. Sine is going to be opposite over hypotenuse. It's pretty much going to be the same thing, right? 1 over square root 2, that's negative. If we write it better, negative square root 2 over 2. Cosecant, square root 2. The tangent is going to be 1 over 1, which is 1, and the cotangent, 1. Now there's not a lot here that is actually new information, right? The only new part is trying to sort out, well, when are they gonna be positive? When are they gonna be negative? The rest of this is a whole bunch of different stuff that we've done, all combined together. Now we've got 7 minutes left in class. Cool. Homework. I think we're good to go. I think we've done enough.